So let's begin by drawing a picture of a Z curve. It is bell-shaped. The mean is 0, and the standard deviation is 1. So the mean is 0 here. Standard deviation is 1. Is about here. The entire area under the curve equals 1. So if we want to shade that, what that means is if we measured all of this, that entire area is 1, and that corresponds to a probability. So we call a probability density function, or a probability distribution. But we're going to take a look at various probabilities, and we're going to read the Z table to do that. For example, if I ask the question, what is the probability that Z is less than 1.25? We want to visualize that, see what it looks like. Drawing the normal curve. 0 is here. 1.25 may be about here. We're interested in the probability Z is less than 1.25, which will correspond to all of this area. Half of the area is to the left of 0. So we know for sure that this answer is going to be more than half. But then we look at our table. 1.25 looks to be 0.8944, reading the Z table. So make sure you watch the YouTube video to see how to read the Z table. If I ask the question, what is the probability Z is greater than 1.25? Let's draw a picture and visualize it. See how this is behaving. 1.25 is still here. But if I want the probability Z is greater than 1.25, we're taking this number, the amount that is to the right. Well, we just saw that the amount to the left is 0.8944. So the amount to the right will be 1 minus 0.8944, which gives us 0.1056. So let's take a look at another similar pair of problems. If I want the probability that Z is less than negative 2.14, we want to visualize this. So we'll draw a Z curve. Negative 2.14 might be about here. Now the probability Z is less than negative 2.14 is this small piece of area. So that tells us right away that we don't expect a very large number. So we're going to go to the Z table, to the negative Z score side, and looking for negative 2.14, 0162. Seems to be what I get when I look at the Z table. And if we take the probability Z is greater than, let's draw the picture. So negative 2.14 is here. 0 in the middle, of course. We want everything to the right. So we can say it'll be a much larger number. But this little area over here is 0.0162. The total area is 1. So to answer this question, we'll take 1 minus 0.0162, which will give us an answer of 0.9838. Okay, continuing. Let's ask the question, what is the probability Z is between negative 1.32 and 0.47? So we are between two numbers this time. Draw the distribution as best you can. Remember, of course, 0 is in the middle. So 0.47 may be here. Negative 1.32 may be here. And what we want is we want the area between. So we are measuring this area between those two numbers. Now the z-table gives us everything to the left. So the z-table will give us everything to the left of 0.47. The z-table will give us everything to the left of negative 1.32. So if I would subtract those two, I would get the area that is between. So to answer this question using the z-table, we're going to take the probability z is less than 0.47 minus the probability z is less than negative 1.32. So looking at the z-table, z is less than 0.47. Go on the positive side of the z-table. 0.47 looks to me to be 0.6772. No, 1 over 0.6808. 0.47 is 0.6808. Minus, then I want to find negative 1.32. So go to the negative side of the table. Negative 1.32. Looks like it is 0.0934. So that if we subtract those, 0.6808 minus 0.0934, we get 0.5874. So 58.74% of the z-scores are between negative 1.32 and 0.47. Let's do one more in that genre. So we'll take the probability that 1.63 is less than z is less than 2.51. So this time we expect the number to be quite a bit smaller. We are to the right of the distribution. So 1.63 might be here, and 2.51 might be here. So all we are looking for is that little bit of area in between those two. Now to the left of 1.63 would be all this area. To the left of 2.51 would be all of that area. So to answer this question, we will take the probability z is less than 2.51 minus the probability z is less than 1.63. So going to the z-table, to the positive side of the z-table, 2.51, 2.50, 2.51, looks like it's 0.9940. Minus the probability z is less than negative 1.63. Negative 1.63 looks like it is 0.0516. So as we subtract those, what do we get? 0.9940 minus 0.0516 gives us 0.9424. That obviously is not correct. So let's go ahead and fix that. 1.63, apparently I was on the negative side. So let's scratch that. 1.63 is what? 1.63, 123 is 9484. So you see the advantage. I realized that my answer was ridiculous, so I went back and checked the table again to say 0.9940 minus 0.9484 to give us a result of 0.0456. And looking at the graph, that seems a whole lot more reasonable than my original answer of 90%. So you really do want to give yourself a visual representation. Let's take a look at some percentiles. So I'm going to ask you to find the z-score that corresponds to the 62nd percentile. So that requires me to think through this backwards. So we're going to go ahead and draw our z. We want it to beat 60% of the population. And we know 0 beats 50%. So if I want 62%, I expect my z-score to be somewhere in here. So I'm going to look at my table for as best I can find to find 0.6200. What is the z-score that corresponds to 0.6200? What's the closest I can get? That'll be my best guess for the 62nd percentile. And if I look, the closest I get 6179, 6217. 6179, 6217. 6179 corresponds to 0.30, z equals 0.30, and 6217 corresponds to z equals 0.31. And my personal preference is to say that the z equals 0.31 will be my better answer because that beats at least 62% of the population. So I would argue that P62 is approximately corresponding to the z value, which is 0.31. So if you have a z-score of 0.31, you will beat at least 62% of your neighbors in that distribution. And let's do one more of those. Find the z-score that corresponds to the 15th percentile. And again, it's always a good idea to draw a picture. We know half of the data is to the left of 0. We only want to beat 15%, so we have a z over here, and that little itty-bitty piece of area here is going to be 0.15. So I'm going to read the body of the table looking for 0.1500, and I'm going to try to see which z-scores come closest to that. Now you can see this has got to be a negative z-score. We are to the left of 0. So going to the negatives, looking for 0.1500, what's the closest I can get to 0.1500? We have 1492 and 1515. So 1492 corresponds to which number? Negative 0.104. Negative 1.04. And 1515, 0.1515, corresponds to negative 0.103. Negative 1.03. Of course, what I meant to say. And I like to have the one that beats at least that many. So I'm going to go with negative 1.03 since that beats at least 15% of the population. So I will say that P15, the 15th percentile, is approximately the same thing as our z-score of negative 1.03. And that will conclude this lesson.